Good morning, everyone. Myself, Prabharan J, working as an assistant professor in EC department at SNS College of Technology. In this lecture video, I am going to discuss about the topic name is liquid level sensor, that is Fabry Perot sensor from unit 3, which is displacement level and flow sensor from the subject name is basics of sensor technology. Let I discuss the empathy stage of design thinking. This is the first stage of design thinking. In this stage, our objective is to deeply understand the user's need, challenges, and frustrations. For liquid level sensor, this means interacting directly with end users such as industrial operator, maintenance engineers, and plant managers. Through direct observation, we can watch how operators handle sensor in real industrial environment and identify the practical problem they face. The key challenges observed include sensor accuracy degradation over time, durability failures in harsh chemical or temperature condition, and complicated installation procedure. From this observation, we derive several key insights. The recurring issues are sensor drift that requires frequent recalibration, complex setup process, and a high total cost ownership. Therefore, empathy help us connect technology development with authenticate user needs, which forms the foundation for effective innovation. Next stage of second stage of design thinking is define. Here we have to frame the problem statement. Here we convert our observations and user feedback into clear actionable problem statement. This step bridges user insight with technical possibility. Based on the empathy research, we can define the core problem as follows. Operators need a highly accurate, reliable, and easy to maintain liquid level sensor for critical industrial applications. The third stage of design thinking is idea stage. In this stage, to conduct a brainstorming session, we have to generate innovative solutions. This stage encourages creativity and divergent thinking to explore multiple solution approaches before selecting the most promising one. We can consider several sensing technology. First, capacitive sensing, which measures dielectric changes but is susceptible to material buildup. Second is ultrasonic technology, which is non-contact but affected by the foam. Third is optical methods, which offer high precision but are traditionally complex and expensive. Finally, Fabry Perot emerges as a strong candidate, providing exceptional sensitivity and immunity to electromagnetic interference. Let me do one classroom activity. Here you can see the diagram. Now you find the what is the value of the question mark. Next stage of design thinking is prototype. Here building the Fabry Perot sensor. In this stage, the design concept is transformed into a model for testing and evaluation. The Fabry Perot sensor operates on the principle of optical interference between two parallel reflective surfaces, forming what is known as Fabry Perot cavity. As the liquid level changes, the cavity length varies, which leads to measurable shift in the interference pattern transmitted through an optical fiber. The core design principle include optical fiber integration, reflective surface engineering, then signal processing. The prototype stage enable us to evaluate sensors core functionality before mass production. The final stage of design thinking is test. Here we have to validate the design and identify areas for improvement. Testing include several steps. First, laboratory testing, where we measure accuracy, repeatability, and response time. And second step is field deployment in real industrial environment to assess durability and usability. Third is collecting user feedback, and finally refining the design by updating calibration algorithm and strengthening the sensor housing. Finally, the application of design thinking to the Fabry Perot liquid level sensor clearly illustrates how human-centered design principle can revolutionize industrial sensing. By following the stages of empathy, define, ideation, prototyping, and testing, we can create sensors that are not only technologically advanced but also valuable and reliable for end users. Let me discuss the assessment quiz. First question is the working principle of Fabry Perot liquid level sensor is based on the optical interference between two reflective surface. The correct option is B. And then the second question is in a Fabry Perot sensor, the cavity length changes due to the movement of reflective mirrors caused by the change in liquid level. The option is B. If you have any doubt, you can ask me through the comment. We will meet in next video. Thank you.